Alright, Assalamu alaikum. So this would inshallah be our last video on O-level electrochemistry, and this is the video in which we'll be, if you can recall the first video with which we started off, there I told you that electrochemistry is basically divided into two parts. That was electrolysis and the other was electrochemical cell. So far we have completed the first branch, that's electrolysis. We covered how to electrolyze molten ionic compounds. Then we covered the process of electrolyzing uh, aqueous ionic compounds, be it concentrated or dilute. And all this was done using inert electrodes. Then in the last two videos, we covered how to electrolyze stuff using active electrodes and the applications of electrolysis using active electrodes. Now finally, we are moving to electrochemical cells. Now if you can recall from the first video, I told you that the purpose of an electrochemical cell was to generate electricity. In electrolysis, what we did was that we provided electricity to an ionic compound to break that ionic compound down. This time, we'll be generating electricity ourselves. So the first requirement for an electrochemical cell firstly would be obviously an electrolyte. And since the purpose of an electrolytic cell is to generate electricity, we will not use a battery here, because that's what the purpose of an electrochemical cell is, to generate electricity. So the second requirement it would be electrodes, obviously. But what kind of electrodes? That's the question. So the condition is that the electrodes that we use would firstly all be metals. And why is that important? Because we can use graphite electrodes as well. But here we will not use graphite electrodes. Instead, the electrodes would be metals, and there is an other catch. We will not use the same metal. Instead, it would be dissimilar metals. This means that if I have copper at one electrode, I cannot have copper at the other electrode. It must be any other metal, maybe iron, maybe zinc, or whatever. So let's get started. Mostly the electrolyte that we use is an acid, for example HCl, H2SO4, or so on. In fact, you might have seen batteries at your houses. The batteries in the cars, the batteries that we use in generators, and the batteries that we use in UPS. All those batteries have electrolytes, and those electrolytes are basically sulfuric acid. And the electrodes are made of lead and lead oxide. But we won't talk about lead oxide here. We'll be keeping things very simple, and our electrodes would be both metals. So let's get started. So here's my container, which contains an acid, let's say sulfuric acid. And now come our electrodes. And as I said, the electrodes would be dissimilar metals, and I'm showing those with different colors. So let's say that this is copper, and let's say that this one is iron. And obviously, we don't need a battery here, but in order to see that electricity is being generated, we'll have something to show us that something is being produced, that electricity is being produced. So what I'll do is that I'll make a voltmeter here, which will tell us that electricity is being produced, and additionally it will tell us what is the voltage of the electricity being produced. So now Now because we have two electrodes, one of them is going to be the cathode and the other is going to be the anode. But there's a problem here. The problem is that in all the electrolysis reactions that we did, we had a battery with us, and that battery helped us identify that which electrode is the cathode and which electrode is the anode, but here we don't have a battery. So how will we decide which electrode is the cathode and which is the anode? So for this reason, we come back to the definition of what a cathode is and what an anode is. The cathode is the electrode at which reduction takes place, and the anode is the reaction is the electrode at which oxidation takes place. This is the first thing. The second thing that will help us decide which electrode is the cathode and which is the anode, we need to understand what exactly a reactive metal is. Now, because we have two dissimilar electrodes, two dissimilar metals forming the electrodes, obviously one of them is going to be more reactive than the other. So let's understand what a reactive metal or any reactive substance is. So a reactive substance is the one which prefers to stay in ionic form rather than elemental form, in ionic rather than elemental form. So if we are talking in terms of metals, we know that a metal is a substance which forms cations only. That is a universal definition of a metal. We'll find metals which are liquids, for example, mercury. We'll find metals which are not shiny. We can find a lot of varieties in metals, but one thing will remain constant for all metals. That is that metals only form cations. So if we are talking about a reactive substance, and if you are referring to reactive metals, then a reactive metal will be a metal which forms cations more readily. And in order to form cations more readily, it must be losing electrons more readily. And we know that loss of electrons is oxidation. So from the reactivity series of metals, we know that iron is the more reactive metal of these two. So we know that a reactive metal is the one which forms cations more readily and hence loses electrons more readily. So what will happen is that this iron is going to lose electrons. The iron metals of this electrode are going to lose electrons and form maybe iron 2 plus. And this iron 2 plus moves into the solution. And as a result of this, electrons are produced. Therefore, this becomes the anode. So the first thing is that the more reactive metal forms the anode. Now, if you recall the first video, I told you that if you are asked to define what an anode is, you'll always say that it's the electrode at which oxidation takes place and and you'll not say that it is the positive electrode. And here is the reason why. Because the anode here is the source of electrons for the cathode, uh, the anode here has a negative charge. So the thing to remember is that in an electrochemical cell, the anode is the negative electrode. And it is for this reason why we'll always prefer to define an anode as the electrode at which oxidation takes place. Why? Because oxidation may not take place because anode can also be can be positive in case of electrolytic cells, and it can be negative in case of electrochemical cells. So now the electrons released at the anode move to the cathode. Here we go. And the cathode is in contact with the hydrogen ions from the electrolyte. These hydrogen ions come in contact with the electrons and form hydrogen gas. Therefore, what we'll observe at the cathode is bubbles of hydrogen gas. So let's write all of this down. So the first thing, as I wrote here, was that the more reactive metal forms the anode, and ions are formed which move into the solution. Therefore, we'll see that the anode will keep on dissolving. The anode is the source of electrons. The atoms that form the anode uh, move into the electrolyte as ions. So therefore, we have our equation Fe, which was a solid. It gives us Fe2 plus 2E minus. So over time, the anode diminishes in size. And what about the electrons? These electrons move to the cathode. So the third thing, I'm writing it here. The electrons move to the cathode where they combine with hydrogen ions from the electrolyte forming bubbles of hydrogen gas. So the cathodic equation would be 2H plus 2E minus gives us H2. This is aqueous and this is a gas. Now this process of formation of bubbles is called polarization. This is called polarization. Now as you can see that electrons are produced at the anode and they move to the cathode. So a flow of charge is established. And because a flow of charge is established, there is a current and a voltage. And therefore, you will see a deflection in this voltmeter, either on this side or this side, whatever, indicating that yes, some electrical energy is being produced. Right, so what are the observations? The first observation is anode diminishes. Alright, I've written, sorry for the spelling error. Diminishes. Number two, bubbles of a gas at the cathode. Now, very important thing. As the as the reaction proceeds and continues as time passes, the anode becomes progressively smaller and smaller and smaller. That means that a time will come when there will be no anode left to continue with the electrolysis, to continue with generating electricity. Therefore, over time, the cell would wear out. Another thing would happen. These bubbles of hydrogen gas which surround the electrode, this cathode, this basically acts as a barrier between the electrode and the hydrogen ions in the solution. So as the reaction proceeds, more and more bubbles of hydrogen gas will surround the cathode and stop the hydrogen ions in the solution from interacting with the electrons that are coming to the cathode from the uh, anode. Therefore, this production of electricity in an electrochemical cell is a self-limiting reaction. So we'll write this down here. I'll type this to make things a bit quicker. Production of electricity using an electrochemical cell is a self-limiting reaction. As the reaction proceeds, more and more of the anode is dissolved. Until it can no longer act as a source of electrons. Right. At the same time, more and more bubbles of hydrogen accumulate at the cathode. I hope I can make this wider. No, I can't. Yes, I can. At the cathode. These bubbles act as a barrier between the hydrogen ions, the H plus in the electrolyte, and the cathode. Thus, over time, no further electrical energy can be generated. So this explains why this reaction is self-limiting. Now, what if I want to produce a higher voltage of electricity? So it's very simple. Now we know that that the reactivities of the anode and the cathode differ. So if the gap between the anode and the cathode is greater, a greater voltage will be produced. And the smaller the gap, the smaller the voltage produced. However, there is a very important limitation, and that is that if the gap between the anode and the cathode is large, it means that the anode is a much more reactive metal, and therefore it will wear out much quicker. As a result, even though we'll get a higher voltage, but the cell won't last much longer. Therefore, if the gap between the metals used at the cathode and the anode in the reactivity series is large, we will get a large voltage, but the duration for which the cell would last would be smaller. That's the end of electrochemistry. If you have any confusions, in the working of an electrochemical cell or any other concept in this chapter, feel free to contact me in the comment section. I'll try to get back to you whenever I get time in either another video or in response to your comments. Uh, with that, Assalamu alaikum, and hopefully we'll meet in some other topic of either chemistry or any other subject.